Alright, so let's look at, we're in chapter 10 still, let's look at guided problem 10.4. Push that shed. Okay, so 3 winter anglers on an ice fishing trip push a 120 kilogram shed out onto the ice. Okay, they are somewhat careless and push in different directions. As seen from above, the forces of these 3 are 32 Newton, the F1S C, so that's contact force, F1. Okay, so 1 refers to one of the anglers, and S refers to the shed, and C is a contact force. Okay, and this is 32 newtons directed 30 degrees east of north. East of north. The second one is pushing at 55 newtons due north. Okay, make sure you know what due north means. This means north, right? And the third force is 41 newtons directed 60 degrees west of north. Question is, what are the magnitude and direction of the shed's acceleration? Okay, so let's see here. The first thing is, look at what they say here. It's a force problem involving 3 vectors. Consider which is more appropriate, graphical addition or addition by components. Okay, so what do they mean by that? Let me just make some space down here. Okay, sorry. Alright, so graphical addition. Let's use blue for, there's our y-axis, and there's our x-axis. Okay, let's choose green. So we've got 3 forces. The first is, I'm just going to draw them roughly here. The first one is this is F1S, and that is equal to 32 degrees. 32 newtons, and it says east of north, right? East of north. Let's just make sure we get that. Directed east of north. So that's east of north. And then there's another one which is, let's make that blue. This one is 55 and it's due north. Okay. And then we've got another one, let's make that red, and it is 41 newtons and it's 60 degrees west of north. So those are the 3. So I just wanted to show this quickly. You can add these up using the head to tail method. This is, by the way, this is the graphical approach, head to tail. Starting with any one, you can add them up in any order. So let's put in, here's F1S. Okay, then you can add this one, head to tail. You put the tail here, and there is I've forgotten now, is that F3S? There's F3S, and then actually, yes, no, that is correct. What's this one? And then you've got one that can go straight up. That's F2S. Okay, and then you've got that's your resultant, your sum of your forces. Okay, so you can add it this way, and that way, or, and I'm actually just going to waste your time if I show you different ways now, but you can start with that one, then this one, or you can start with that one, and you just keep adding them head to tail. You will always end up with the same resultant force, okay, pointed in that direction. So that is the graphical way. Obviously it's possible, but it seems a bit more complicated to me to determine the angles. You can use the cos rule and the sine rule, but the way that I prefer it is to simply start again, is to use the component method, where you've got you've got each force. There's my 55 Newton. Okay, then what was the other one? Then this is the, this was, what was this value? That was 32, and that's 30 degrees. And then we also had this one, which was 41 Newton, 60 degrees. Okay, so the way that I prefer it is now we say, well, we know that the sum of the forces is mass times acceleration, and we're looking for this acceleration vector. So we can break it up into x and y. So sum of the forces in the x, this is 30. We have, this is F1s, okay, this is F2s, and that is F3s. So now we need to break it up into its x and y components. So that is F1sx, and there is my F1sy. Remember, when we break it up into components, we have to remove the actual force, because otherwise we're going to double up. So we've got F1sx over here in the x component. Does this force, does it have any x component? No, it doesn't. So we can move on to this one. Then this one is going to be F3sx. Okay, so we've got only two components in the x direction, and this equals mass times acceleration in the x. Now what would this be? This is going to be 32. So we're looking for this component here. Okay, so it's going to be sine 30. Sine 30. Okay, opposite over hypotenuse. Opposite. Okay, or if you wanted to make this 60, you could say cos 60. Okay, so this is 30. And then this is going to be in the negative direction. If we make this positive, that's in the negative direction. So it's going to be 41 sine 60 or cos 30, sine 60. So minus 41 sine 60 is equal to 120 AX. And this is on the left here is minus 19.5. Make sure that you get that, 120 AX. And so AX is what? It's basically minus 0.163 meters per second squared. So these forces cause an acceleration in the x direction of minus 0.163. So there's an acceleration in that direction of 0.163. Okay, so I know it's pretty scruffy, but now let's look at the y direction. Again, sum of the forces in the y is mass times acceleration in the y. Now I meant to say this, sum of the forces here in the x is mass times acceleration in the x. So what's happening in the y direction? Well, we've got a y component for this force, it's this one. We have a y component for this force, and we have a y component for this force. Okay, so what would this guy be? It's going to be 32, and it's going to be cos 60. Okay, we take that as positive, and then we're going to add our 55 because the force is directed in the y direction. It's due north. And then we're going to add this component here, which is simply 41 cos 60, right? Cos 60 equals 120, that's your mass, times the acceleration in the y direction. So this gives us 103.2 is equal to 120 AY. And then AY is 0.86 meters per second squared. Okay, so now we've got our two components. We've got AX and we've got AY. Okay. So, again, if we've got our X and Y, our AY is in the vertical direction. That is, again, it's a vector, so so AY is 0.86. It's in the Y direction, and then AX is minus 0.163. So it's right there. So remember, it's minus 0.163. Okay. So what is our resultant? Let's get another color. Right, so our resultant is that, right? So using the parallelogram there. So, I mean, just use your imagination. That should be a straight line. So we need now two things. We need a magnitude, and we need a direction. What is the magnitude? Well, it's simple. It's 0.86 squared plus minus 0.163 squared, square root. And the textbook tells me that value is 0.875 meters per second squared. So the resultant acceleration is 0.875 meters per second squared. And what is the angle? Well, you can use tan to the -1 of we can do this, minus 0.163 over 0.86. That equals theta, by the way. That's theta. Theta. Okay. And theta gives us, we are given, the answer here is 10.7 degrees. 10.7 degrees, okay? So we've got our magnitude and we've got our direction. Alright, so it's 10.7 degrees west of north, and the magnitude is that. Okay. Alright, cheers.